Even without seeing the surface of a planet, we can make some reasonable assumptions about what is likely to be going on there based on some basic information like mass, distance, and composition of the world. In this question, we're going to look at how some of the data in the mystery solar system can give us hints about what is happening on the surfaces of planets. Note that this question specifies the largest inner planet. We don't work with outer planets here, since most outer planets in these systems don't have any solid surfaces, so there aren't any geologic processes to discuss on them. There are four important types of surface processes: impact cratering, volcanism, tectonics, and erosion. However, different planets have different amounts of each of them. Impact cratering is common on all worlds with a solid surface. While it's usually much more common in the early history of a solar system, it continues at a low level throughout a planetary system's history. A terrestrial planet with an atmosphere can filter out the smaller impactors, but the ones that produce large craters generally aren't even slowed down much by these atmospheres. Volcanism and tectonics are based on the internal heating of the planet. In a previous question, you determined whether or not this planet has enough internal heat to have a convective mantle. If it's got convection in the mantle, then it's likely to have volcanic and tectonic activity. Also note that a planet can have signs of past volcanism and tectonics even if they're not active now. When we look at a world like Mars, we see signs that it used to be very geologically active, but this has declined a lot over the last few billion years. In fact, worlds around the size of Mars are in that transitional range between very active worlds like Earth and Venus and very dead worlds like the Moon and Mercury. Anything more than a couple of times the mass of Mars should have plenty of volcanism and tectonics, while anything much smaller than Mars probably has very little such history. Erosion on a planetary surface depends on several factors. First, the planet has to have an atmosphere. Later in the course, we'll look at how you can directly measure the presence of an atmosphere, but for now, you can use a simple rule of thumb that a planet that is hot enough for mantle convection can have a substantial atmosphere, while planets that have never been very active inside probably don't. A world that was only active earlier in its history, such as Mars, can have a thin atmosphere left over from its past. But being big enough isn't all you need for erosion. Air or liquids have to be moving around on the surface. For a planet to have wind erosion, it has to be spinning reasonably quickly. If the spin period is hundreds or thousands of hours, the spin rate is slow enough that it may be difficult to get strong winds. To have water erosion, the surface temperature has to be reasonable for liquid water. You can figure this out by calculating the surface temperature using Wien's law. Look back at how we did the surface temperature calculation in an earlier assignment. Don't try to use the no greenhouse temperature given in the table. That's not necessarily a good estimate of the actual surface temperature. Also remember that water freezes around 270 Kelvin and boils around 370 Kelvin. So if you're getting temperatures much outside of that range, water isn't likely on the surface. Finally, if the temperature is below 300 Kelvin but above 200 Kelvin, then there's a chance of glacial erosion on parts of the surface. The temperature has to be warm enough that the bottom layer of the glacier can melt to provide lubrication to allow the glacier to move. Make sure when you're answering this question to be very clear on what data you're using and what it tells you. For example, if you're arguing that the temperature is reasonable for liquid water, make sure you say what that temperature is and show how you got it. The previous part of the question asked about general processes. In Part B, you should take the next step and speculate on what the surface will actually look like. For example, do you expect rivers and oceans, vast fields of ice, lots of active volcanoes, fields of cracks like on the surface of Venus, or moving continents like on Earth? Should there be lots of impact craters visible or very few? This is your opportunity to really start imagining what this world is like. Look over the range of features we've already seen on planets in our own solar system and suggest possibilities here. The main limitation is that your answer has to be consistent with what you said about the geologic processes on this world in Part A and the data in the Mystery Solar System table. Also, make sure you cite what information you're using to suggest what this world is like. Part C is a companion to Part B. It asks for important geologic features that might be missing from this world. One reasonable option here is impact craters. If there's a lot of other geologic activity, then impact craters will have been mostly erased, as has happened on the Earth. Also, if the temperature is too hot or too cold for liquid water, then you wouldn't expect rivers or oceans to be present. Is the planet too hot for glaciers? Is it too small for active volcanism? Once again, ground your answers in the earlier parts of this question and the data in your Mystery Solar System table.